is.
So if you want to hack Jeremiah, that's where you target.
Gee, thanks. Okay.
That's where I target.
So, okay, so we did the history stealing hack. So again, JavaScript won't help you there. And but what about this port scanning stuff? Can you port scan? You know how we did the JavaScript port scanning stuff? Can we do it without JavaScript, right? So that was the big trick out there, you know. And it turns out that we can. So in HTML, there's a particular link, the link tag here, that has a really interesting side effect. So what happens here is this particular tag will actually halt the page from rendering until after the request has come back. It's a really odd behavior for this tag, but it makes sense in a lot of ways. But this will halt processing. So what happens here is this page is served, and these two tags are made. These two lines are made. It's actually less code than the JavaScript hack. And this is the epoch seconds of when the page was served. So while this is waiting here, if this is waiting a long time to be served, waiting for the timeout to request, it'll halt the page and not hit the secondary image tag. When it hits the secondary image tag, it has the same IP that you checked for. And then when it hits the server does an epoch seconds again. And if the time between the current epoch seconds and the time the page was served, if it's close, the web server was up. If it was long, the web server was not. So it actually is very good for, you know, surfing for web servers or, well, anything else. You see if host could be alive, but not necessarily listening for a web server, or there could be a web server there, but it provides reconnaissance. Straight HTML, you can't turn it off, right? Unless you go back to links, I guess. So
we'll do links next year.
We're going, what is that? We're going not Web 2.0 hacking, we're doing 0.9?
0.9,
yeah, I got you.
exactly.
So I'll show you how this works. I'm going to test fate here, and actually I'm going to connect to the BlackHat wireless and get an IP. Let's see here. Let's see if I can get an IP.
Mom always told me not to do live demos.
Yeah, really. Okay, so I will, hopefully this worked. So this is right here. This is all, you know, if you're going to do port scanning and all this kind of browser hacking, it's got to be database backend. So this particular screen is showing all the sites that have that I've captured that have internal host names. This is just login facilities. And this is the web page I'm going to be using here that the user will stumble across. My IP here, this machine here, is actually running a web server on 10.01.55. So hack away, you got 10 minutes. And I'm going to hit reload here in my browser. Now notice here, there's a bunch of iframes on the screen. Okay? Now these could be invisible, doesn't really matter. But the first thing you should notice here, these are all the IPs I'm scanning for. And the first box is, this right here. The first box here is a broken image. That's because the image tag called. Our measurement tag got called because the web server was up. So right here, what we're going to do is I'm going to show you the source. View, frame, source. And I'll pull it over here so you can see it. In that frame is our link tag going into the 55 address and the epoch seconds. So again, two quick tags. And the rest of the tags and the rest of the pages, the iframes are waiting for that timeout to hit because there's nothing there. So they're just waiting there real quick. And at 75 seconds in, which is pretty standard, you can actually see in the status bar here it connecting to the addresses, and all of a sudden it'll stop, and that's when we'll go view the logs. So this is actually one thing you might notice is it's a little slow, but there are ways. I'll show you a trick in a second on how to speed the process up. So right now, see the timeout hit. All the next requests went out. And we probably can see the requests go out down the bottom here, but it's going to be hard to dig out. But we're going to go here, hit reload. And so now you see what should be here in the external is the user's external IP address, the one that we would have captured if this was on the public internet, but right now we're just using localhost. Here's all the internal IPs we scanned for. 55 here, notice the delta was 1. It was 1 second off, between the time the page was served and the time the image request got called. The rest were in the 74, 75 second time frame, so you know those hosts are not up. They're not they're not active, or there's no web server listening, but they're basically dead. So very quick, very easy, quick timing hack. And given that you're scanning the intranet, The timing attacks actually work quite well because there's no latency on the internal zones. I mean, or very little latency, not like there would be on the public internet. Everybody got really concerned again. Okay.
Talk about port restrictions.
Yes, we'll talk about port restrictions. So actually, we don't have time to go through.
Okay.
So, sorry, we were going to do.
Afterwards, we'll talk about
If
port
we have time, we'll do some port restriction bypassing in Firefox. So now I mentioned this is slow, and when we, but what's it? But by the person by the name of Elia, and I'll just butcher the last name, so I'm not even going to try it. I came up with a clever technique to speed the process up through something I didn't know about. It's something called a content type multi-part X mixed replaced. Fortunately for IE, they don't support this particular content type, but Firefox and Mozilla do. Okay, so the way this works is that if there's a content type of that, what the web server can do to beat the timeout to speed up the attack is that they can on the fly replace the current HTML with more HTML. So let's say you're waiting 10 seconds and that should be enough. You don't want to wait for the full 75 of the timeout. You just slam in another link tag at an image source using this mechanism here, and it's real quick. I think probably just as fast as the JavaScript scanning out there, maybe even faster. And again, it's there, it's workable, code is available, and it works quite nicely.
Very clever.
So, where has that gotten us to? Like we said before, who needs Web 2.0 hacking when when Web 0.9 works just fine? Who really disables JavaScript anyway?
7 people.
7 people. Okay, that's why I said okay, outside of this room.
It's even less outside the room.
Yeah. So, and then what happens when JavaScript malware, even if you have all these extensions on, are on sites that you trust? The social networking websites, the webmail providers, the web bank providers, and things like that. So we've done some pretty cool JavaScript-less hacking. We'll try to come back to this topic if we have more time to do some filter, the port restriction bypass. But a lot of us here, especially those outside here, not on the road, are VPN'd in, right? So let's try to get some VPN hacking going. I'll let RSnake take it away on this one.
So this all came about through a conversation I was having with the Erratasec guys, and by the way, they're speaking here tomorrow, in interesting ways that you could potentially use split VPN tunnels to hack in, because part of that traffic is unencrypted. So theoretically, there's bad things to be done there, which we'll get to in a little bit. But one of the bad things about split VPN tunnels is it's basically like you're being inside your intranet. It's not exactly like being inside your intranet because part of that content is not necessarily filtered by like WebSense, for instance, and the intranet might have some protection around sending erroneous or antivirus or whatever through the front end, but through the VPN, maybe there aren't those types of things. It's just a different interface with different access controls, different security mechanisms. So basically what we were able to do is get you to go to badguy.com somehow. And because those websites, we don't have WebSense running, you're allowed to go to badguy.com. Maybe you wouldn't have been if you're at work, because you're not allowed to surf porn at work or whatever. But when you're at home, sure, go right ahead. And I still want to check my email while I'm surfing porn, so that's great. That's great for me. So basically, using passive reconnaissance, I can find out their internal IP address, or I can use active stuff like the CSS history hacking stuff. There's a couple of other ways to do that as well. Some really noisy de-anonymization stuff as well, but we're not going to get into that. But referrer leaking we will talk about a little bit later. So this is just a diagram trying to explain, and I'll show a demo in a second, trying to explain what the difference is. So you're actually sitting outside in the cloud, but you're still having some amount of access, whether it's through SSL VPNs or not, to your corporate intranet. Badguy.com does not have access back end, but they do have access to allow you to get access on their behalf. So you want to switch the thing? I'll switch the demo.
You want to have 3 or 2?
3. All right. So let's go to log. This is just a logging function. This is what the bad guy is particularly interested in. This is where eventually we're going to see some intranet data. So if I try to connect to the intranet right now, I'm not going to be able to do it. I'm not connected to the VPN. So I boot up my OpenVPN. It can be any VPN client as long as it's split tunnel. this is incredibly slow because there's a number of VMs running in the background. So now I click on Internet, and so this is the super secret stuff that I'm not technically supposed to share out with the world or whatever, all classified information. It could be anything. In this case, I'm using an outdated version of MediaWiki, and I'm talking about how Google is investing in our business idea to read people's brains, because we all know Google's evil. I don't hate Google, I just crush a lot. So I go to badguy.com because it's interesting because Fidel Castro is a pimp, and he shops at pimppats.com. And why do I know that? Because I too shop at pimppats.com. But anyway, down here below we see this iframe could be hidden. It doesn't matter. In this case, I didn't make it hidden so we could see what's going on. I'll turn off JavaScript and show you what the source looks like. So basically, I just iframe an XSS exploit, the well-known MediaWiki exploit. So maybe I knew they were running MediaWiki, maybe I had some other reconnaissance, maybe I have 50 vulnerabilities in a row that I just brute force and try them, whatever. Somehow I was able to do that. So if I go to that, you'll see that this is the source of the page. It's basically just standard cross-site scripting, nothing special. And I should point out that this didn't have to be cross-site scripting. It could have been an XP command shell. It could have been PHP remote file include or whatever. This example just makes it a little easier to see and a lot easier to build. So basically, a very simple exploit. It's just opening an XML HTTP request to / which is the base directory of wherever it's being called. In this case, it's the intranet web page. And it's sending that information to bad guys, this post.cgi with the content in it. So now if I look back at log CGI, I get to see that Eric Schmidt's brain is pure evil.
So you might want to go through that one time where right at the moment they get hacked, so they can see how quick it is.
Yeah, so it's incredibly fast. I mean, if you're looking at this web page, let's turn on JavaScript again. It's that fast. So basically it made several requests. It pulled in JavaScript. It ran JavaScript on the page. It made an XML page request to / whatever's in the base directory, pulled that information in, threw it in a post form, submitted it back to badguy.com, all within about a second.
So you surf a page and VPN'd in, you hit the wrong page at the wrong time, and the internet is owned real quick, and it's gone.
Yep.
And any traces? Any tracks?
The only thing it looks like is that you, a corporate user, tried to exploit your intranet. The bad guy, I mean, other than the fact that the bad guy's JavaScript was injected, is pretty much out of the picture. So he probably used an own machine. So what are you're going to find some server in Korea or something that really has nothing to do with you. I should point out that this is actually made a lot worse by Didi. I don't know if he's here in the audience or not, but was talking to me about NTLM. A lot of corporate intranets use NTLM to make it easier to authenticate. You authenticate once, you don't have to worry about it ever again. You just kind of click and you're automatically authenticated every time you go to the other page. So HR, you log in, go to intranet, you're still logged in and all that stuff. It's great for unified authentication. It's also incredibly bad for this stuff. Once you're authenticated, I don't get the htaccess dialog. There's no worries about me dealing with your authentication system. You're basically allowing me to make my job as an attacker much, much easier. So
a lot of people ask, we hit the wrong web page.